So, welcome to lecture number 21 of fuzzy sets, logic and systems and applications. So, this lecture is in continuation to our discussions on arithmetic operations, and these arithmetic operations are on fuzzy numbers. We have already covered the arithmetic operation, that is the addition on fuzzy numbers in our last lecture. Today we will be discussing the subtraction of fuzzy numbers. So, when we have two fuzzy numbers a and b, and these two fuzzy numbers are within some universe of discourse capital X, and if we perform the subtraction, it results in a new fuzzy number, let us say C, and this C can be defined as C is equal to A minus B. So, please note here that A and B both are fuzzy numbers. So, what does this mean here is, if we say A is a fuzzy number, means A is a fuzzy set which satisfies the criteria of normality as well as the convexity. So, we can say A is a normal fuzzy set and A is a convex fuzzy set. Similarly, B also is a normal fuzzy set and convex fuzzy set. Now, when we subtract B from A fuzzy numbers, we have a C fuzzy number which is again a convex and normal fuzzy set. So, for discrete fuzzy sets, the subtraction will governed by this equation here. So, C is nothing but C will be equal to the summation of mu x of C is equal to summation of mu C x C oblique x C over the universe of discourse capital X. So, this is for discrete fuzzy sets, and for continuous fuzzy set this summation will be replaced by the integration sign. Please note that this summation is a symbolic representation here. Similarly, the integration is also a symbolic representation. We do not have to either sum or integrate. So, these have to be there, these values, these terms in summation we have to just separate by plus signs, and in integration we do not have to integrate the whatever is the outcome, because of course, here there is no dx or something like that. So, the resultant fuzzy set, that is coming out of A minus B as C. So, C will have a membership function and it is a generic variable. So, mu C here can be found by mu A minus B of x C, where C is nothing but the resultant fuzzy number, and this is equal to the max of min of mu A x A and mu B x B over x A x B. So, it is clearly understood that x C is equal to x A minus x B for subtraction purpose, and for all x A, x B, x C, they are belonging, all values are belonging to the universe of discourse. So, we can write here the C is nothing but C is represented by this expression. So, let us now take an example of subtraction of fuzzy numbers A and B and understand the operation. So, if we have two fuzzy sets A and B, A is equal to 0.3 oblique 1 plus 0.6 oblique 2 plus 1 oblique 3 plus 0.7 oblique 4 plus 0.2 oblique 5. B is represented as B is equal to 0.5 oblique 10 plus 1 oblique 11 plus 0.5 oblique 12, and both these A and B sets are discrete fuzzy sets. And these are represented here as the fuzzy numbers A and B. So, let us now apply the formula that we have just seen, what is resulting. So, C is equal to A minus B, C is resulting fuzzy number here, and this is equal to the fuzzy number A minus fuzzy number B. And when we apply this formula, let us see what is happening. So, first let us compute this value for one combination of the elements from A and B. So, let us take min of these two, this term and this term. So, 0.3 oblique 1 and 0.5 oblique 10, we have two elements, and let us take min of these. So, min of 0.3 and 0.5, we are going to get 0.3, and then here for generic variable value, since we are subtracting, so we will simply subtract. So, the generic variable value will be the x c here for this case, and x c will be here nothing but x a minus x b, x c is equal to x a minus x b, and this is here in this case x a is 1 and x b is 10. So, what we are going to get here is minus 9. So, that is how we have computed here, and the value of this term here, when we have taken the one combination, and this combination, the first combination is giving us 0.3 oblique minus 9 for A minus B. So, similarly for all the combinations of elements of fuzzy number A and fuzzy number B. So, we will follow the same procedure for finding the other elements for corresponding to the other combinations. So, let us quickly go through this, and we find the other elements here as 0.3 oblique minus 10. So, this we will get out of this. So, when we have these two pairs, we clearly see that the min of 0.3 and 1, we are going to get 0.3. So, that is for how this 0.3 is coming, and then this is the outcome of the generic variable valued subtraction. So, 1 minus here 11. So, this is going to give us minus 10, which is here. So, on the same lines here we go ahead and find all the combinations. So, this way we take all these combinations of pairs, we get these values coming. You can see here is shown by the outcome of each and every pair is coming and shown in the red color, you see here. So, that is how we are getting the subtraction of all these pairs. So, that is how we get the complete total terms, the total elements, the total outcomes are listed. Now, what we have to do is we rearrange all these terms, means we form a group of all these elements which are having same generic variable value. So, for generic variable value minus 11 we have only one term. So, that is how it is written here. Now, for generic variable value minus 10 we have two values. The first one is this and the second one is this. So, we see that we have two terms for generic variable value minus 10. Similarly, we go ahead with all the generic variable values that are listed here and we form a group of same generic variable values, and then we apply the max criteria. We take the max of membership values of the same generic variable values. So, let us now go ahead and see what is happening here, and when we do that we see. So, here we are now applying the max, and when we apply the max we see here this is the term which is having two membership values. First membership is 0.5 and the second membership here is 0.3 for the same generic variable value minus 10. So, for minus 10 we will have to have only one membership value which is 0.5 when we take max of 0.5 and 0.3. So, that is how we are getting here 0.5. So, we here we can say here that we are applying the max in between or max of 0.5 and 0.3. So, that is how we are getting 0.5 and this 0.5 is coming over here. And on the same lines we are obtaining all these terms. So, for corresponding to minus 9 we are getting 0.6, minus 8 we are getting 1, minus 7 we are getting 0.7, minus 6 we are getting 0.5, minus 5 we are getting 0.2. So, all these terms we have got here, and now we can clearly see that there is no duplication, or in other words we can say there is no duplication in the sense that we do not have here more than two values of generic variables. Means we have only the generic variable minus 10, we do not have other places minus 10. So, it means we have the generic variable value minus 11 and then minus 10, minus 9, minus 8, minus 7, minus 6, minus 5 like that. So, this way we have obtained the expression for C and we can clearly see that this is a fuzzy number. And now, let us plot this fuzzy number C, which is the outcome of A minus B here. So, fuzzy number A minus fuzzy number B, we have fuzzy number C, and C is, you see here also in this case comparatively we have more spread than A and B. So, this is because the uncertainty level in the fuzzy number C is increased. So, when we have a fuzzy number A which has some uncertainty level, and again we have fuzzy number B which also has some uncertainty level, and when we take A minus B or A plus B. So, the outcome fuzzy set which is a fuzzy number in both the cases will have comparatively more spread. So, it means the uncertainty level gets increased, and please understand that this uncertainty that I am talking of is the uncertainty due to ambiguity, imprecision and vagueness. So, in this category this uncertainty is normally accounted in the fuzzy sets. Now, let us find the subtraction B minus A. So, let us now subtract fuzzy number A from fuzzy number B and see what is happening. So, on the same lines as we have discussed A minus B. So, we have seen that we have first computed the min of the membership values of corresponding terms, corresponding pairs, and then when we have all these pairs we have found, then we moved ahead and we took max of these and then we moved ahead. So, we can quickly go through this and see what is happening here when we subtract fuzzy number A from fuzzy number B. So, we can directly here go through this, and here also when we subtract fuzzy number A from fuzzy number B, we see that we have mu B of x B min mu A of x A oblique x B minus x A here. X B minus x A is because we are subtracting fuzzy number A from fuzzy number B. So, here when we take the min of the corresponding membership values, we see here that we get 0.3, and then when we subtract here 1 from 10, we are getting 9. So, 0.3 oblique 9 we are getting as one of the terms of fuzzy number C, which is the outcome of B minus A. So, similarly for all the combinations of elements of fuzzy number B and fuzzy number A, we will follow the same procedure. So, we see here that we are getting C as, if we see here, we are getting here result of B minus A fuzzy numbers, we get 0.2 oblique 5 plus 0.5 oblique 6 plus 0.7 oblique 7 plus 1.0 oblique 8 plus 0.6 oblique 9 plus 0.5 oblique 10 plus 0.3 oblique 11. Now, our B minus A is coming here as fuzzy number C, which is plotted here, and when we clearly see that this is very similar to the outcome which we got in the earlier case of B minus A. So, when we bring these two outcomes A minus B and B minus A together, we see that these two are symmetric. So, or in other words we can say that A minus B and B minus A both are the mirror images of each other. Of course, here we see when we take A minus B and B minus A, we see that these two are not equal to each other. So, it means the commutativity property does not hold good with respect to the subtraction. Now, let us discuss the multiplication of fuzzy numbers. So, multiplication can be defined here as C is equal to A star B. So, star here signifies the multiplication. So, and A, B, C are fuzzy sets where A and B both are the fuzzy numbers. So, once again I would like to mention that when we say fuzzy number, it means it is fuzzy set which is satisfying both the properties, the convexity as well as the normality. So, when we say here A and B both are fuzzy numbers, it means both the sets A and B are the normal fuzzy sets as well as convex fuzzy sets. So, here we use this formula for finding out the fuzzy set, the multiplication of A and B, and which is resulting, let us say C fuzzy set, this is the A star B. So, of course, when we multiply any two fuzzy number, we are going to get a fuzzy set out of it. This fuzzy set here may not be fuzzy number, because this may not satisfy the criteria of the normality as well as the convexity. So, we will see ahead what is happening when we multiply two fuzzy numbers. So, let us quickly go ahead and see how do we multiply two fuzzy numbers. So, formula remains the same. We see the only difference that we see here is this x c comes out to be x a multiplied by x b, which is here as well, which is mentioned. So, other than this there is no difference at all. So, all min and max remains intact. So, we need to be careful while finding the multiplication of two fuzzy numbers a and b. So, in addition this x c was x a plus x b. In subtraction the x c was x a minus x b. So, in multiplication here we have x c which is equal to x a into x b. So, let us quickly go through an example here which will make us understand little better the multiplication of two fuzzy numbers. So, here we have the fuzzy numbers a and b, and these fuzzy numbers here are within the universe of discourse minus 15 to 15. So, here we have to consider the universe of discourse as well. Now, let us find the multiplication of these two fuzzy numbers. So, when we plot the fuzzy number a, this will look like this. When we plot the fuzzy number b, this will look like this. Here it is shown by the green color, and fuzzy number a is shown by the blue color. So, let us now apply the formulation that we have just discussed, and when we apply, we first try to find this term, which is mu a of x a min mu b of x b oblique x a into x b. So, let us quickly find out these values mu a x a, mu b x b from this pair, the first combination. So, we have first combination here, and from here we get all these values mu a x a, mu b x b, and also we get x a and x b as generic variable values. 0.3 is mu a x a, 0.5 is mu b x b. So, when we substitute here and take the min of this, we find the min as 0.3 and 1 into 10, which are the generic variable values of a and b respectively as x a and x b. So, when we multiply this, we are going to get 10. So, this is going to result 0.3 oblique 10. So, similarly for all the combinations of elements of fuzzy number a and fuzzy number b, we will follow the same procedure, and that is how we are going to get 0.3 all the elements as 0.3 oblique 10, 0.3 oblique 11, 0.3 oblique 12, 0.5 oblique 20, 0.6 oblique 22, 0.5 oblique 24, 0.5 oblique 30, 1.0 oblique 33, 0.5 oblique 36, 0.5 oblique 40, 0.7 oblique 44, 0.5 oblique 48, 0.2 oblique 50, 0.2 oblique 55, 0.2 oblique 60. So, all these elements we have got after computing minimum of mu a x a and mu b x b oblique x a into x b from all the combinations that are possible from fuzzy number a and b. So, when we have done that, that will result here these terms. So, when we rearrange, when we write all these terms, we see that we have all these terms are some of the terms that are there which are not within the universe of discourse. So, let us see what we need to do further. Since the universe of discourse that has been given to us is minus 15 to 15, it means whatever elements that we will be having or that will be getting here should be within the universe of discourse. So, this means what? This means we have to consider only those terms for which we have the generic variable values within this universe of discourse. So, this way if we look here in this expression, so we see that we have generic variable value 10 which is within the universe of discourse, 11 which is within the universe of discourse, 12 which is within the universe of discourse. So, like that these are within the universe of discourse, these values, these generic variable values. Now, what about this 20? So, 20 is not within the universe of discourse. Similarly, 22 also is not within the universe of discourse that has been given to us. Similarly, 24 which is also not within the universe of discourse. Similarly, 30 is also not within the universe of discourse. 33 is also not within the universe of discourse. 36 is also not within the universe of discourse. 40 is also not within the universe of discourse. 44 is also not within the universe of discourse. 48 is also not within the universe of discourse. 50 is also not within the universe of discourse. 55 is also not within the universe of discourse. 60 is also not within the universe of discourse. Only 10 is within the universe of discourse. This 10 as the generic variable value. So, this generic variable value is within the universe of discourse. Then 11 is within the universe of discourse. 12 is also within the universe of discourse. So, when we have now known this thing that only 10, 11, 12 are the generic variable values present here are the part of the universe of discourse. So, we will take up only those terms which are having the generic variable values within the universe of discourse. So, it means we are only considering these 3 terms, and these 3 terms we see here that 0.3 oblique 10, 0.3 oblique 11, 0.3 oblique 12. These 3 are lying within the universe of discourse, which is minus 15 to 15. And when we plot this outcome here as fuzzy set C, this is not a fuzzy number, because you see this does not qualify to be a fuzzy number, because this is not a normal set. So, this is a fuzzy set C. This is not a fuzzy number, please note that. So, this way when we have a fuzzy number A and fuzzy number B, when we multiply this as A star B, or in other words we can say when A and B both are fuzzy numbers and they are multiplied, we are going to get a fuzzy set, and this is not going to be the fuzzy number in our case here. So, in a more appropriate way I would say that the multiplication of 2 fuzzy numbers may not be a fuzzy number. So, now let us find the B star A, means now let us take B first and then A. So, let us now see what is happening. So, when we do that and we apply the same procedure of computing B multiplication A, we see that we are getting here after doing all the computations and intermediate steps. So, we are landing up here again we are landing up with only 3 elements, means the same elements. So, when we plot this B star A, means when we multiply B and A, we get the same set. So, we can say the A multiplication B is equal to B multiplication A, means A and B, the multiplication of the fuzzy numbers A and B are commutative with respect to multiplication. So, this way we see that here both the fuzzy sets are same, and as I mentioned earlier that these are not the fuzzy numbers, the result is not a fuzzy number here. Please understand that since we have limited the universe of discourse, we have shown only a portion of the actual multiplication. We could have seen some more terms which would have been spread probably in wider universe of discourse, but here since the universe of discourse is very limited. So, that is why only few terms are coming as or few terms are included within the universe of discourse, few terms are included here and in fuzzy set C. So, that is why you can see here how these two look like within the universe of discourse minus 15, 15. And as I already mentioned, A multiplication B is equal to B multiplication A. So, that is how we have seen as to how we can multiply two fuzzy numbers A and B. So, with this we will stop here, and in the next lecture we will study the division of fuzzy numbers, and apart from this we will do some more examples on the addition, subtraction, multiplication and division of fuzzy numbers. Thank you.